Everybody loves fresh baked desserts, but how many times has this happened to you? You just baked a fresh batch of pumpkin bars. You pull them out of the oven and put them on the counter to cool. You leave them there for hours, and when you come back to eat your delicious dessert, they're still just too hot. Or how about when you're sitting down for lunch to enjoy a nice bowl of noodles, but you end up scalding yourself? Or what about when you make a fresh cup of hot coffee? You leave it on the counter to cool, but you forget it there for just a little bit too long. All of these problems can be solved with one simple solution: calculus. Calculus can be used to predict the temperature of cooling baked goods at any given time. We can do this by using Newton's law of cooling.
Newton's law of cooling states that the rate of change in y is proportional to the difference between y and t. This can be written as y prime equals k times y minus t, where t equals room temperature, y equals object temperature, and x will equal time. To solve, we first take the integral of both sides. The left side is dy over y minus t. The integral of a function that is derivative over original is natural log of the original, giving us ln of y minus t. The right side is a constant multiplier k, making the integral kx plus c. Now we need to solve for y. To do this, take e to the kx plus c and e to the ln of y minus t. The natural log and e cancel each other out, giving us e to the kx plus c equals y minus t. We can move c to the front as a constant multiplier. Now add t to both sides. This gives us an equation for y. We now need to find c. We will solve for c at time 0. First, plug in 0 for x. Anything with an exponent of 0 equals 1, giving us c times 1 plus t equals y. Now subtract t from both sides. This gives us c equals original temperature minus room temperature. Plug that in for c. Our final equation is y0 minus t times e to the kx plus t equals y.
We used Newton's law of cooling to predict the temperature of several items, starting with banana bread. To use Newton's law, we needed to take the temperature of the room and the initial temperature of the banana bread when we took it out of the oven. After 10 minutes, we took the temperature again. We plugged our data into the equation: the room temperature, initial temperature of the banana bread, the time, 10 minutes, and the temperature at 10 minutes. Then we solved for k to get our constant. We plugged k into the original equation and were able to predict the temperature of the bread at 20 minutes with only a 0.3% error. We used the same method to predict the temperatures of coffee and cupcakes. So remember, next time you're baking and don't want to burn yourself, use calculus.